Good morning. I was going to wait till the room was more filled because there's a big queue coming down in order to register, but in order not to lose too much time, and Gus, our moderator, has already told me I shouldn't be speaking too long, and especially give the floor after our panelists to you. I will first of all say a few words about, and I hope, Gus, that you will be good at that, because what I'm expecting is a lively discussion. If we are going to have a panel of all people that agree on the same thing, this is not going to be very interesting. So I'm counting on you to give different perspectives. And Gus, I invite you to provoke that with all of our panelists. So Gus, he's the moderator. He is the executive director of Privacy International, a London-based charity that conducts litigation in the UK and across Europe, leads research and advocacy across the world, and runs a network of partner organizations in the Global South. Does that cover you? Panelists, Seda, all the way back there. Seda Gürses, she is a postdoctoral research associate at CITP, Princeton University, and an FWO fellow at COSIC, University of Leuven, and works on privacy and requirements engineering, pets, cybersecurity, and surveillance. All of that in one go. Glyn Moody. Glyn? Yes. Glyn, he's a freelance journalist who writes and speaks about privacy, surveillance, digital rights, open source, copyright, patents, and general policy issues involving digital technology. Then we have Catherine van de Heyning, is a criminal lawyer at the Brussels bar, postdoctoral researcher at the University of Antwerp, and is visiting professor in criminal law at UCLL in Diepenbeek. She works on the protection of procedural rights in the European legal space with a specific interest in the impact of digitalization of crime on these rights. Pat Walshe. Pat, he is the director of Privacy Matters Limited, and a data protection and privacy consultant with an experience of nearly 20 years in the field, with special passion for the role of technology and data. Then Phil Zimmermann is cryptographer, privacy activist, and is the creator of PGP and Silent Phone, a secure VoIP product. He recently joined the Faculty of Cybersecurity at TU Delft and also serves as an advisor on cryptographic matters. He was introduced into the Internet Hall of Fame, the Cybersecurity Hall of Fame, and received the Privacy Champion Award from Epic. So, very, I would say, famous, notorious maybe panel. And I'm Patrick Penninckx. I'm the head of the Information Society Department of the Council of Europe, dealing with, on the one side, everything to do with data protection, but also in the same department with cybercrime. And sometimes this tension actually that prevails in my department is also prevailing for the Council of Europe. On the one side, what do we need to do in terms of securing human rights online as we secure them offline, and ensuring that our data are private and protected. And at the same time, we have a number of issues dealing with criminal investigations through the Cybercrime Convention, but also our work on terrorism, our work on organized crime. So there is this dichotomy also within the Council of Europe, and I think it's important that we also deal with that. Gus, the floor is yours.
Good morning, everyone. Thanks for joining us. I can't believe it's the 10th Cpdp, and also I can't believe we're still talking about crypto. It is, when they asked me to organize a panel on crypto, I thought, oh, come on, not again. I can't believe we're still having this debate. But we are, and yet, actually, the debate is about to get a hell of a lot more interesting. And I think just the past year, if you look at what's occurred in the past year, compared to where we were a year ago at Cpdp to now, all the things that have changed in the crypto debate or the crypto wars or whatever you want to call it. This time last year, we didn't know about Apple v. FBI. We didn't see that fight coming. And yet it dominated the first quarter of the year when it came to surveillance policy. This time last year, we didn't have UK and Dutch legislation allowing for hacking of technology, hacking of devices, lawful hacking by government, by police and intelligence agencies. This time last year, we were waiting for President Hillary Clinton to start her Manhattan Project to solve the crypto problem. That was her promise, that somehow she'd get the best engineers on the planet to sort out what her husband as president tried to sort out when we had key escrow. This time last year, the idea of state hacking was limited to governments hacking essential infrastructure and Sony. And then this time last year, we didn't know about the phenomenal case study that came out because of the incredible work of Citizen Lab about the NSO Group and its product that helped the Bahraini government attack the devices of Bahraini human rights advocates. That then led to Apple updating its operating system on every device, every iOS device across the world. The last year has been fascinating. And so I don't want a debate about key escrow. I don't want a debate around just the weakening of crypto as we've understood it over the years. We've essentially identified the 5 paths that the crypto wars are heading down in the foreseeable future. And let me just quickly identify them and then hand over to the fantastic panel so you can hear their thoughts, and then we can get some discussion in the room. The first, I actually don't believe governments are going to ban crypto. It's not a serious proposal on the table. So let's just throw that one aside for a moment and focus on what they're actually trying to do. And the first one is that they're trying to ensure that they can demand keys, whether they can demand your password, demand access to your key, or as we saw in the case of the United Kingdom, the police are now seizing devices while you're on the phone so that they don't have to unlock the device. Or, of course, they're using forensic technology in order to get access to the data on the device. The second type of policy is the crypto backdoor. It is the essential golden key that the FBI is still looking for, and governments across Europe think they can find some common ground with what would have been President Clinton's Manhattan-level project. The third is where things start to get much murkier. It's when we start asking industry to do things to their services. Now, that could be as relatively simple as demanding more data from consumers, or profiling their consumers in a way to monitor for terrorist activity, or something along those lines. But we're not seeing that debate in an open forum. We're hearing rumors of this type of collusion with industry. The fourth is when we actually governments start asking industry to tamper with security. And that was the Apple FBI example. The Apple FBI case, just so everybody's on the same page, it wasn't about weakening crypto. It wasn't about a backdoor to crypto. It was about an alternative operating system. And now in the United Kingdom legislation, there is the power to secretly demand that a company assist the government in penetrating security. And there's a gag order on any company that complies. So Apple FBI occurred in the US. It would never occur in the public domain in the UK. And that's a direction of travel of legislation. And then the fifth and final dimension is government hacking, like direct government hacking. And as I mentioned, Dutch and British law recently passed now makes this a legal act, although we're questioning it all the way to the European Court of Human Rights. But there are going to be ramifications around the power of government to hack devices and infrastructure and services that we all need to start exploring. So this panel is going to be looking at those 5 dimensions, but essentially asking, what does this mean for the legal process, such as evidence procedures? What does this mean for industry, who were unable to participate in this panel, unfortunately? What does this mean for internet security, cybersecurity policy? Of course, what does this mean for human rights? And the direction of travel with innovation. What does this actually mean? Again, just to use the example of the United Kingdom, now when a company changes its security on its product, it has to notify the UK government first. Any company anywhere in the world. That's in the name of law enforcement, but one wonders what are the ramifications for innovation and for cybersecurity and internet security more generally. So the format of the panel, so we're going to ask each panelist to speak for a few minutes based on a question. that I'll be posing them, and then we'll open up to the audience as quickly as possible so we can get a dynamic debate in the room. So the first speaker is going to be Phil Zimmermann, who was introduced before, and you all know. Phil, you've seen the hard edge of government intervention in the crypto domain. Where is U.S. policy heading in this domain, you think?
Well, I think that my ability to answer the question of where is U.S. policy heading would have been different if the election had turned out differently. But yesterday, the Trump administration is directing the Environmental Protection Agency to remove all references to climate change from their website. The Environmental Protection Agency can't talk about climate change. So nobody would have imagined that would have been possible. So if the scale of radical change is such that the EPA can't talk about climate change on their website, then trying to predict where the U.S. policy is heading, we saw Trump's remarks about the Apple FBI confrontation. My guess is that it's probably going to be heading in the direction that Trump wants it to head, and that'll be bad. Just really bad. I'm used to thinking of U.S. policy on crypto and other matters as being a very high inertia system that's determined by large-scale realities, bureaucratic sort of institutional knowledge of the issues, and that's something that doesn't change so fast. But if the EPA has to remove references to climate change, then it appears to be a very low inertia system now. So anyway, yeah, maybe I went on too long about that.
Okay, thank you. Catherine, from your experiences in criminal cases, what is law enforcement actually doing with encryption or about encryption, and where do you think it's actually heading to?
Yeah. So in popular media, I think the focus has been mostly put on the hacking because it's quite new, and there are some new bills, because you mentioned UK and Netherlands, but also in Belgium a lot is moving, and we've got new legislation which would allow law enforcement to go much further. And on the other hand, there has been a lot of attention, of course, on cooperation duties. I call it cooperation duties because obviously United States legislation is different from the European, but in fact it comes down to that there's a duty for internet service providers to cooperate, and that they can be sanctioned criminally or civilly if they don't cooperate. Most attention has been put on those elements. However, if you look at the actual practice of law enforcement, it's only a minority of the cases where this is put in place. There are, on the other hand, other measures that law enforcement at this moment actually is putting in place and is relying on a daily basis to circumvent encryption. And the first one we've seen in several cases in Europe and United States is, of course, to have a cooperation duty on a suspect or a third party. Third party could be a spouse, or could be friends, or could be other people who are on a cooperation duty. If they don't cooperate, there can be a criminal sanction. Of course, from a rights of defense perspective, this is really troublesome, because then you will get the debate on, doesn't this violate the prohibition against self-incrimination? And I would say, if we would have had this panel in November, I would have said that there is a clear consensus growing that this is not the way to go, that there is a clear violation of rights of defense if you would put such a cooperation duty on suspects. However, at this moment, I have seen in December and this month that this kind of proposal are again being pushed by law enforcement in the United States, and I wouldn't be surprised to see them in the European Union as well, and this will go up to the European Court of Human Rights, no doubt. So that's one element, cooperation duty on suspects. A second element where encryption, where law enforcement is trying to circumvent encryption, is infiltration. It's a very old technique. You basically place a police or a civil person into a network, and you're going to infiltrate in the network, and you're going to just take part in the conversation, which I believe is not only a classic way of doing investigation, but is also a very helpful way, and is one that doesn't, well, undermine the collective security in that encryption provides us, and is actually a viable and creative way to work around encryption. And the third way, and which is an important way for law enforcement these days, is actually to work with the metadata. To accept that, okay, we can't necessarily get into the encryption conversation, into the content, but we work with metadata. This as well in the European Union today is put under pressure because of the new judgment of the European Court of Justice that proclaimed that the retention of data should be limited. And most of you will, it's a different debate, but also that puts again the pressure from law enforcement on getting actual access to data. A last element which law enforcement is really pushing on the agenda is cooperation on the technological side. And in the end, once again, if we would have had this discussion on November, I would have told you that there is a growing consensus, both in the United States and the European Union, among law enforcement, that actually providing for backdoors, etc., is not the way to go, and that encryption is actually a valuable tool, and that the focus is now being put on technological measures and cooperation, resources, better cooperation with ISPs to have new ways to collect data. This is all really, at this moment, I can't say that consensus is growing, because since November, since the election of President Trump, we're actually seeing that some law enforcement officials who have proclaimed that there is a growing consensus are backtracking, and in particular from perspectives of the FBA, we see new initiatives to actually push forward to backdoors. So I would say that is the whole field of what law enforcement is playing at this moment.
Is it possible, I'd like to follow up on, I spent a little too much time on drawing EPA comparisons. You know, if you try to project what policy direction is likely to emerge from underlying technology realities, I think we can infer some things from this, because the underlying technology is kind of, you know, we've had for centuries an arms race between cryptographers and cryptanalysts, and from time to time one or the other has been ahead or behind. In World War II, the cryptanalysts were ahead. Today, the cryptographers are ahead. The best crypto is ahead of the best cryptanalysis. But in fact, it's been that way for like the past 40 years. But for other aspects of cybersecurity, the attackers have the upper hand. And it's extremely lopsided in favor of the attackers. It's just hopelessly in favor of the attackers. And so what we saw from the Snowden material is that the NSA takes advantage of the other vulnerabilities in a system. They, you know, if they can't cryptanalyze PGP or some other strong crypto package, they'll go after getting into the platform and taking control of the compute platform. And they've had enormous success with that. So that's where, so sometimes policy naturally follows the flow of technology. And that's, you know, that's where I think policy has tended to go, recognizing the reality of the technology. So we're probably going to see a continuation of that. But we're probably going to see from the Trump administration an effort to try to get vendors to soften up their technology. But I think vendors are going to try very hard to fight that. All the vendors I talk to say they're going to try very hard to fight that. But with, you know, analysis of metadata, traffic analysis, and trying to get into the platform in other ways, they'll find a way in.
That's the perfect segue to Pat. Pat's bio was actually quite liberal. Pat used to work in the telecommunications industry, who are well known for their, let's say, close and special relationship with government. Also, Pat used to work for the GSMA, which is the Mobile Phone Industry Association. That was one of the targets of the NSA, or GCHQ, I can't remember which, when it came to hacking, their use of hacking powers. Now, I'm sure you can't comment on either of those situations too much, but I'd love to explore, if you could explore with us, based on your experience of what industry has done in the past, and that's large industry, the telecommunications industry, and the internet industry is certainly large, but less close to government. But is that possibly a dynamic that will change?
Yeah, so I guess another little bit that wasn't on my bio, so I did all that, but I also used to run a team that did government interception and disclosure, and I've negotiated with different governments, and I've been subject to some of these secret orders, and it's problematic. But just to set the scene slightly, we're talking here about surveillance, really. We wrap it up in a crypto term. But some of the realities that telcos face and that struggle through trying to find solutions is that, yeah, I dealt with an association that had 800 mobile phone operators around the world. Each of those operators depends on the largesse of the government for a license to function, to make money. Those license conditions, every single one that I've inspected, and that's many of them, not 800, but a great many of them, has an obligation in there to establish and maintain the capability to lawfully intercept communications. Some license conditions in some countries actually forbid the bulk deployment of encryption without the approval of the government. So these are some of the pressures that carriers are under. They also then may face secret directions that require them to do things, such as in the UK, we had a Section 94, which was a secret order. You can talk about them now because it's all out in the public domain, but that was where the government would issue an order against a telecom operator to do anything. That could be to retain data in bulk, it could be to give them access to certain people roaming overseas, all sorts of things. Now, the only thing that you had there was that telcos could resist under a particular civil action, of course, but none did, of course, all acquiesced. And I think when you compare that to, say, Apple and Microsoft, who fought in the public domain against these things, that shows you actually, are telcos willing to fight? And I think Glyn will talk, looking at his notes here, there's no such thing as privacy. We'll talk a little bit about some of those things, I'm sure. But what can industry do? What will they do? When I look at the IP Act in the UK, which certainly has it extends the power of the Secretary of State to issue equipment interference orders against telcos, and that means to put equipment directly into telco premises. Now, I fought for 4 years to prevent the precursor to the IP Act, to prevent the government doing these things. Because currently, telcos act as the gatekeeper in the UK. So they act where requests come in, everyone is vetted. Where interception warrants come in, they are personally vetted and they are personally and manually implemented. That's the way it acts. Under the IP Act, that will disappear. So you've got one level of protection is removed. Now let me just, because we're not just talking about the UK, and this is something interesting that I find. We have a telephone company that's divesting its operations in Eurasia. So these are countries, for example, Azerbaijan, Georgia, Kazakhstan, Moldova, Tajikistan, Uzbekistan, all gleaming examples of human rights, compliance and respect, right? So what this company admits is that its local companies are required, for example, using a Soviet Union system called SUM, to give direct access to their networks and to their equipment for intercepting all telephone traffic, monitoring internet and voice over VoIP, for example, monitoring all communications media and enabling the long-term storage of data. Now, what this company admits is that it has no way of knowing how often and for what purpose communications is accessed. But I find interesting here, Gus, that it's not just about industry. So this company is 37% owned by the Swedish government. So what does that mean? What does that mean? You've got a Swedish government that has its own approach to human rights, to addressing these things, and it owns 37% of a company that operates in countries where there is this system of monitoring, which goes directly against the Zakharov case, Russia case in the European Court of Human Rights, which quite clearly said, for example, that these things are unlawful and unnecessary in the age that we live in. That these systems of surveillance should not exist as they do currently. And in the UK, not only do we have the IP Act, but worryingly, we have calls recently that we will come out of the European Convention on Human Rights. At that point is when, like Paul, I will go and get my Irish passport.
But Pat, if I could just push you, because we accept, not happily, that the telecommunications industry is very close to government, and the licensing regime does kick that off. But you were quite generous towards the internet industry in your comments. What do you think the internet industry is going to have to do? You think they can continue to be aloof, distant, not mentioning Yahoo, for instance, but what do you think is going to happen? Are they going to be targeted in the same way?
Yeah, I think under the IP Act, certainly in the UK, definitely there's no distinction, really. When you talk about telecom operator, the way that the IP Act is written, it's going to capture those. It's going to capture the cloud service providers that deal with communications data, for example, and OTT messaging services. That equally is going to be caught. So they're going to come under this pressure. And I think WhatsApp is a great case in point, right? And Phil may want to jump in here. We've had wonderful debates, crypto debates, all the serious security, crypto geeks in the world have been uniting against The Guardian, saying it was wrong to say there's a backdoor. Okay, it's a vulnerability. No, it's not a vulnerability. And this is where WhatsApp deploys the Signal protocol, but not in the same way. And it may be on the WhatsApp that if someone changes their phone, you may not know about that. Messages that haven't been delivered could be delivered to someone else, for example. That's possible. And all that debate has been around the fact that the content is encrypted, right? Because that's where the focus is. Let's encrypt the content. Difference between these two different services is that one doesn't generate and retain the metadata, but the other one does generate an awful lot of metadata because actually that's fundamental to its business model. It requires that data to survive. It requires that data to make money. And it links that data to shadow profiles. So actually, when it comes to law enforcement, it isn't crypto that's going to matter. It's actually that the metadata exists. So the other question then in relation to the UK law is if that metadata is encrypted, well, that matters not a jot because those telcos or others will have to ensure that it's available and accessible in an encrypted form to the government, to the security services and to law enforcement agencies. And worryingly, when I look through a proposed code of practice, Gus, on equipment interference, it means technically that the security services should be able to search en masse across all of those databases in real time. Now that's a worrying step up from my perspective and a chilling step up.
Thank you. Glyn, if I can go to you, it's not all about industry, is it? And I just wonder if you can paint the picture of the United Kingdom a little bit more wholly.
I'll talk about that second bit first. So it's very interesting, some of the things that have been raised. I just specify what those are for those who aren't quite sure. They're called communication service providers, but as Pat says, that probably means just about everybody. And they're required, this is from the Code of Practice, to provide a technical capability to give effect to interception, equipment interference, bulk acquisition warrants, or communications data acquisition authorizations. It specifically mentions removing encryption, and as Gus mentioned earlier, if a company comes out with a new product, it has to tell the government in case the government by any chance should want that to be broken in some way as well. So it's pretty bad stuff in every respect. Personally, I think it's going to kill the UK software industry, because why would you buy a product from a UK company knowing that it's probably going to have a back door in it? Why would any government allow that product within their country? So all this business about supporting the UK industry is just hollow words when you're actually going to destroy the software industry. My other point, which is what Gus referred to, is that everything so far has been framed in terms of two players, two actors, the government and industry. There is a third actor, which, speaking as a journalist, is very important because I've been writing about it for 20 years, and that actor is open source. Because you can obviously always force a company to do something, because otherwise they go out of business. I suspect it's going to be rather harder to force a distributed development methodology to do what you wanted. So when you've got open source encryption products, when you've got open source communication protocols, a government can say, well, we don't like that, stop it. And the community will say, well, tough. Here it is in a server in somewhere, people are going to download it. You are going to have to shut down practically your entire internet, as indeed China now does. I mean, we've just seen the Great Firewall of China plug in the holes specifically to do this kind of thing. Either the governments of the West, particularly the UK government, goes that route, or open source will always be that third factor, because it just won't obey these rules, and there won't be any leverage on it because there are no companies actually writing the code. Maybe companies using the code, but the people writing the code are the very ones, particularly who call it free software, not open source, because they believe in freedom. They will actually make it stronger just because the government tells them not to. So I would urge people to think about open source as a major factor here, because I don't know how the government's going to react to open source ultimately. Because when they get all their companies obeying them and just doing what they're told, there's still going to be open source. And so what do they do then? Are they going to ban open source? I mean, I wouldn't put it past the present UK government to try and do that, but I don't think it's a very good route. But it'd be interesting to talk about that afterwards.
If I could just push back just a little bit on that. Like, there's open source and free software, but running an infrastructure is expensive and requires reliance upon companies. Aren't they the weak link? The whole concern that Signal uses Google's servers for syncing.
Well, that's if you're right, you need some kind of infrastructure, but there's no reason why you can't just send things over that neutrally. So basically, you use somebody else's infrastructure, but they don't have anything to do with the actual traffic that goes over it. And so, you can wrap things within things. And I think it's possible to use existing infrastructures, even though those are under control of governments. So, I mean, you're absolutely right that there are always companies involved at some level of the stack, but I'm pretty confident hackers will find a way around that.
I founded a company called Silent Circle, and we have an infrastructure that routes messages and phone calls. And we try to minimize the amount of data that we're collecting, just enough to route the phone call. Sometimes we keep debugging logs for a few days while we fix a technical problem. But we don't do the kind of things that Facebook and WhatsApp do, because that's part of their business model. There's a couple of observations here about the ability for government to impose backdoors. To some extent, the government needs this technology. I mean, I make a product that's used by SEAL Team 6, and the guys that killed bin Laden, need secure communications. They're not going to use our product if we put backdoors in. How are you going to, it's too difficult for intel agencies to build their own secure communications. When you have people traveling internationally, you don't want them to be stopped at the border by some foreign border guards who ask them why they're carrying NSA secure phones in their suitcases. They have to blend in. That means they have to just download stuff from the App Store. Now, regarding downloading stuff from the App Store, that's unfortunately another bottleneck. There's all this talk about open source. I publish source code to all my crypto software for the past 25 years. I recommend that you not use crypto software unless you can inspect the source code. But that's not enough, because the app stores are a bottleneck. They're a throttle, a choke point. It's possible for the App Store to tamper with what can be downloaded, or maybe just impose regulations on. So if Trump wanted Apple to stop selling crypto apps in their App Store, if Apple didn't fight back ferociously enough, the App Store is the only place where people can download apps for iOS. Now, you might say, well, we'll just use Android. Well, you know, the Google Play is the dominant app store there. While it's possible to download apps from other places, well, you know, you can't just do everything on Android. Apple's got a powerful ecosystem. Plus, they have the most secure hardware. Apple's hardware, iOS, has a secure enclave, a hardware-backed secure enclave for protecting cryptographic keys. The Android universe doesn't have that because of the balkanization of, you know, hundreds of makers of Android phones. Apple has monolithic control, and they use that to build this wonderful hardware secure enclave. So if you want to get the most secure platform, you know, you're better off with something that has a hardware secure enclave. Maybe someday we're going to see that emerge in the Android world. But for now, if you want to use iOS, you've got the App Store choke point. So from a public policy perspective, that choke point could be used with a sufficiently determined government effort, a severe ideology that says we will stop, you know, crypto products. You know, if there was an administration in Washington that was sufficiently motivated, maybe they could get Apple to insist on back doors. I don't know. Then what would SEAL Team 6 do?
The news from last night was that senior members of the Democratic Party in the United States are now using Signal. That just introduces a whole new dimension to any clampdowns. The discussion on security.
But on iOS, Signal has to go through the App Store.
Absolutely, yeah, totally. That's a good segue to Seda. What is the direction of travel on the security discourse and the cybersecurity discourse, and how can we actually reconcile this with encryption policy?
Right. A lot of the research I do is to kind of look at how we keep up the infrastructure of cryptography. We don't think about crypto as an infrastructure, but in fact, to have encryption, we have to have almost government scale infrastructure called mathematics departments, electrical engineering departments, computer science departments. They need to be funded. A lot of crypto depends on this infrastructure. So one of the things I've been doing recently is to look at the cybersecurity research and development strategy of the United States to follow what they are saying about the future of encryption. And that was my intention this morning. It's a $1.7 billion a year budget that goes into defining the research. Where are they going? So just in preparation, I thought I would go online to get the latest of the documents. Also, there has now been a separate document called the Privacy Research and Development Strategy published by the Obama administration. However, all the links that I found on Google that went to official government sites of the White House got me to a website called the Transition Splash, meaning that the research and development strategy documents have been removed. Therefore, everything that I say from now on is irrelevant. That was a very hard start to this morning, I have to say. I will tell you what were the plans over the last 4 or 5 years as reflected in the research and development strategy documents. And with another modesty account, the documents, of course, talk mainly about things that are not classified. So I do not know what kind of research and development funds are being put into classified stuff, where I think a lot of the government hacking stuff is coming out of. And I'm talking about research, right? I'm talking about things being projected to the next 10 to 20, maybe 50 years. So not the latest one, but the 2011 research and development strategy said that we basically can't have security. So we need to move towards resilience. That was their thing. They said we cannot embed trust into the internet and the systems that we have as is. Instead, we need to build systems that are resilient, meaning that they survive attacks. They detect them, they notice the damage, they come back, they bounce back. This is very, very different from a lot of people who work on encryption. They think that you should not allow the attackers in. Here, the assumption is that the attacker is already in, and we should move away from assuming that security is mainly about confidentiality and integrity, and think about how we keep our services going, meaning focus on availability. So the shift from security to resilience, some call it from preventive security to preemptive security, has, let's say, 2 or 3, depending on how you count, elements. One is basically using a lot of machine learning and preemptive filtering of activities on networks. and the dynamic redistribution of data across cloud computing networks. This means that the idea is that you watch the networks all the time to identify what looks like attacker behavior, and you stop it from happening in the future again, and so you develop signatures. This is basically equivalent to having all the larger companies, but also smaller ones, doing surveillance of all networks all the time. It also clashes with encryption, because if you want to look at the traffic, oftentimes encryption will get in the way. So there are all sorts of different ways to kind of man-in-the-middle encryption systems so that you can do some deep packet inspection. I think it's very clear that these kind of technologies are in conflict with confidentiality and anonymity guarantees that build on a lot of the crypto technologies that we're talking about. The second, or if you want, second and third leg are deception and obfuscation. Here, the idea is how can we increase the cost of attackers? It's too cheap to attack these systems. And propositions here include dynamic decoys, disinformation, code diversity, and general obfuscation. For those of you who are not very technical, it basically means we make the systems very confusing by putting either noise, changing the code base, things that we do, for example, if we use open source, for example, crypto, one of the things we want to do is integrity checks, right? And some of the propositions here for code diversity basically says we should compile different sets of codes each time, just to make sure that, every time an attacker goes for a specific application, the code is different, so the attack needs to change as well. But it also means that we can't do integrity checks the way we know. So the question is, will that become a research topic in itself? But most importantly, there's a big attack with these kind of techniques on integrity checks that we're used to doing as a part of security in the kind of security sense that I was talking about earlier, not resilience. This is already something that the industry does as well. If you talk with people who do cybersecurity, they will say that they're doing network monitoring. They will say that they're using some sort of obfuscation and deception. Honeypots is the classical example. And we're seeing the consequences of this for privacy technologies, for example, in Turkey. So one of the things, and this is kind of related to the app environment, not necessarily the network monitoring. It was suggested that a group of people who were suspected of having put on the very unacceptable military coup that happened, the attempt at least this summer in Turkey, it was said that this group was using an app called Bylock. It had no good encryption. People analyze the software as basically not very useful, but they were said to be using this software application, and so all of the people who had downloaded and used the software were seen as suspects in the case and are under government investigation. Also, what has now happened is that the Turkish government has managed to convince ISPs to, we're assuming, fingerprint Tor traffic and VPN traffic, so that VPNs and Tor are basically close to impossible to access from Turkey right now. Melih Kurludo, who's here, I don't know if he's in the room, if he puts his hand up. He's doing work on this, so if you want to talk with him in detail afterwards, you should do so. So I guess what I'm trying to say is that while the government research strategy is not necessarily to break crypto, at least not the unclassified research, basically all of the other mechanisms under cybersecurity, which are then often augmented with legislation, like in the case of the US, the Cybersecurity Information Sharing and Protection Act, creates a whole other infrastructure which has a different philosophy of security. It's called resilience, and it basically breaks the basic assumptions about the environment that cryptographers need to have working applications. I think that would be my contribution.
That's fantastic. Thank you. So I hope you understand what we're trying to do on this panel. It wasn't to say the crypto wars are won. It wasn't to say the crypto wars are lost. This is a completely different domain we're dealing with right now. And we have to look at all the moving parts and the changes in philosophy, the changes in technology, and the changes in who is actually an attacker to understand what does security mean going forward, and where does human rights fit into it, where does legal process fit into it. The design of the panel was to introduce as much of an opportunity for the audience to ask questions and make comments. So we have left a lot of time for that. It was a bit of a risky maneuver for 8:45 in the morning panel on the first day, but I'm hoping there's burgeoning questions dying to come out of you. So please, let's open up to the floor. Paul?
You could just yell. Yeah, just yell.
Paul Burnell from the University of East Anglia. My question is kind of from a UK perspective. What our lovely government has done with the Investigatory Powers Act, amongst other things, has attempted to get extraterritoriality built into the system. So effectively, all the various different powers that have been discussed, particularly by Pat and by Glyn, they can attempt to enforce in some way on anybody, anywhere. Do you, when we look at infrastructure and things like that, do you see this as being one of the kind of trends? Are we in the UK helping to make things worse in that way? Not just in relation to encryption and backdoors and so on, but in relation to the kind of metadata workaround, if you see what I mean. Is this something you see as becoming the norm, that actually all the law enforcement agencies all over the world will be attempting to get access to everything?
Well, the U.S. has often tried to do extraterritoriality on a number of their laws. And once you open the Pandora's box for that, then you have Russia and China and North Korea and Iran having their judicial systems issue court orders and extradition requests to other countries. And usually those extradition requests are turned away because those countries are regarded as, not very good models of human rights. But I'm not so sure that the Trump administration would turn down a Russian court that's seeking to extradite a journalist, a Russian journalist who's taken refuge in the U.S. Might just hand him over to his buddy Putin, and maybe extraterritoriality could. We have to be careful about making that the norm.
So Paul, I think it is problematic. I hope you can all hear me. So I think it is particularly problematic when you think of mobile. It's international and it's interoperable by nature. So it's quite possible, for example, here's just a scenario. This may not be reality. It may be one of Trump's alternative realities, who knows. But it's quite possible that when someone from the UK roams in a particular area, or it could be that the UK government has an interest in people who visit a specific region, for example, that they use one of these powers to ask that UK operator to disclose data in a targeted bulk manner of those individuals. Now, why wouldn't a foreign government ask the UK government to do that? Now, if you go back to the Telecom Act 1984, that's an act in the UK that used to regulate interception, etc. What the government did was to repeal the majority of that some years ago, except for a couple of pieces. And one of those pieces was that let the government continue to issue these Section 94 secret orders to telecom companies to do anything that was in that order, and telcos could not discuss it, nor could Parliament discuss this. That's how secret it was. There was another piece of that that wasn't repealed, and I need to find out where it is in the IP Act precisely, where they will cooperate with requests from foreign governments to do similar things. So I see that the IP Act creates for me that same shadow, to be honest.
Finally, also to follow up on the question, as Gus mentioned in the introduction, of course, encryption debate is not a new one, but it has intensified last year. And that's exactly the same with the jurisdiction debate. Also, that debate, jurisdiction on cyberspace, has been running for many, many years, but it has intensified last year. And in particular, law enforcement is challenged by the traditional ways of cooperating with other states via mutual legal assistance treaty, because they are quite well, it takes a lot of time. And that's why a lot of governments are now trying either to make their own territorial space to encompass this complete cyberspace, or the UK perspective that it should be possible to search extraterritorial. On that perspective, however, I'm not too concerned with the Trump administration. Why? Because most of the ISPs that will be targeted will be US. And there will be a US interest, a commercial, economic US interest, to actually go and protect that territoriality of the United States. And there has been a draft from the Obama legislation to actually rethink the way to cooperate with other states to give data on territoriality basis, which actually strengthens American cyberspace territoriality and would make it harder actually from other states to interfere. But on the other hand, to improve the cooperation, that it would be smoother. And on that perspective, I do think the Trump administration would follow on because it is in economic US interest. But I'm very curious to see in the UK to what extent it will be used, because obviously there will be, I mean, on the other hand, other countries will refute that. And it is at this moment at the EU agenda, so in 2017, there will be a new effort at the level of the European Union to rethink territoriality and jurisdiction cooperation at the EU level. Obviously, for the UK, that's not a relevant remark. Yeah.
But just to add a level of cynicism, which isn't fully accurate, so don't quote me on this, but Pat says the mobile industry is a global industry, but that's happening also in the internet industry. Post-Brexit, what have you heard in the United Kingdom? Snapchat's opening up its offices or expanding its offices. Facebook's doubling down on its offices. Google's investing $1 billion to build its headquarters there. Apple's building a new building there. It's the extraterritorial thing. It's no longer that there be Californian companies only based in California. They're everywhere. And they don't seem to be afraid of this. Now, in their law enforcement side of the organizations, when they respond to consultations, they always say, well, this is a terrible thing. Extraterritorial power should not exist in this way. But their business side is expanding everywhere. And so at the same time Apple FBI was arising, Apple's investing more and more in China. Apple's investing more and more in India. So that entire landscape is becoming much more like the telecommunications sector than it is like the Silicon Valley geographic market only. Next question.
Yeah, thanks very much. Lee Bygrave, University of Oslo. Gus, you pointed us along 5 paths along which the crypto wars seem to be heading. And I just want to suggest possibly a 6th path, and that has to do with government agencies' use of encryption themselves. And I was interested if any of the panelists might want to reflect about how encryption itself is used by various government agencies. And I mean, I think several of you have given some indications. You were talking about the use by the Navy SEALs of certain encryption abilities in their hunt for Osama bin Laden, and then well, who knows? And then Katharina, you also sort of touching on, I guess, data sovereignty issues in the latter part of your remarks, and surely this must be factored in here, but I'm obviously it's difficult to generalize.
Yeah. Does anybody want to take that?
Well, if you're trying to produce products that are used by, elite military forces or law enforcement or other government agencies, you can't put backdoors in. They're not going to use it if you do. Especially, I mean, and also, if you're going to be selling to one government like that, you're going to be selling to allies, like the British government, for example, or the American government, the British government, the Canadian government. They're not going to use a product that has any kind of backdoor. So I just want to add something else about what kinds of pressures we could bring to bear on this. Culturally, engineers are against backdoors. Apple engineers, there were Apple engineers that were going to quit if they were compelled to cooperate with the FBI, what the FBI was asking for Apple. Apple engineers were going to quit rather than do that. If a lot of engineers take that position, that would help resist this kind of thing. And culturally, engineers, at least the ones in Silicon Valley, tend to have that kind of libertarian philosophy. I don't know whether European engineers are quite as hard-edged about it, but certainly the Silicon Valley engineers are. And I mean, the engineers that work for me, they tend to be that way as well.
There was only something you said and Phil said, really, Gus, when you were talking about Apple relocating, and we talk about Apple and we hold them up as this champion, right? But in China, recently they took down the New York Times app at the request of the Chinese government. So what happens when the Chinese government say, well, we don't want the Silent Circle app in there, we don't want Signal in there, we don't want WhatsApp in there. Actually, these become fundamental tools that people use to begin to protect themselves. And actually, this whole debate has been about privacy, really, and confidentiality communications. But, we should be talking about human rights by design, not privacy by design. The fact that my communications and the metadata around it affects so many of my fundamental rights. I've seen the consequences of this. You only have to think back to Ukraine and the uprisings from 2 years ago. And where the government targeted all protesters, sent them a text message because they knew where they were. Now, how they knew where they were is another matter, but they knew where they were and sent them a text message saying, we know you are a protester,
Yeah.
you're on our database.
Cell towers.
Yeah, well, yeah. There's a range of reasons why they know where they were. But so it's really important that we begin to think of these things. But when we talk about Apple, so I'd like to know if Apple's going to take down the New York Times, is it going to take down Silent Circle, or is it going to take down WhatsApp or Signal because the Chinese government say, well, actually, we don't want people to have these tools?
And just to add a further dimension to the question, the presumption is that encryption is at this layer. And what would be interesting to find out is what are governments using for hardware. I don't know if you saw the story last week that emerged at Google for its servers farms. It builds its own hardware for its servers. It doesn't trust hardware built off the shelf by other companies or in other countries. I wonder to what extent governments are completely happy for us to use all the same software and for a government to use that exact same software, but they have a completely different platform upon which they do so. And why can't we have access to that? And that would be a particularly interesting domain of research that we need to do far more on going forward and stop focusing just on the code, but look at the layers beneath that. Stephanie.
Thanks very much. Stephanie Perrin, University of Toronto. And it's a fascinating discussion. I would never try and debate with this crowd whether or not there were back doors, but recent statements by President Trump about how everything will be manufactured in America by Americans using American. Autopact is most recent, American car parts, American steel for the pipelines. Leads me to believe that any back doors will be American manufactured on American soil, not necessarily in, say, Google Britain or Google wherever. I'm just wondering how Europeans, I'm leaving out the UK because, of course, I presume that the Five Eyes will persist, but how does Europe view this, and what's it going to do to networks? And this is kind of a corollary to the discussion you had a minute ago about what do you do about global networks? But what do you do about these products? And is Apple going to be able to continue to manufacture in China under these rules?
It's an extraordinary reversal from the 1990s where the U.S. had all the wisdom and all the knowledge, and export controls limited its flow around the world. Now it's a complete reversal of that, if that image that you're painting actually comes true, that it's the vulnerabilities built in, made in America. That is then exported to the rest of the world. Does the panel have any thoughts on that?
Yeah, I remember my friend Brian Snow, who was who worked at NSA. He's been retired for many years, but he worked in the Information Assurance Directorate, which is the side of NSA that tries to protect communications. He said he was worried about how everything was made in China and that American military contractors who were building, say, a jet fighter would be using electronics that, for the flight avionics, where the components are made in China. That's quite worrisome, It makes it very hard to build American, if the British want to build their own, they have to worry about parts made in China. It's not so much whether the parts are made in the US, it's whether they're made in China, since everything is made in China. Everything. As far as, you mentioned Google is building servers that have some special hardware components. Google, I just read a couple weeks ago that Google has some special hardware that I couldn't get a lot of detail from reading the press article, but it sounded like it's analogous to Apple's hardware security enclave for cryptographic keys, that you can do that at the server level as well. Sounds like a great idea. If that's what Google is doing, then I'm glad. It's about time. Maybe there's a way for the rest of us to get that in our servers as well. As far as American backdoors is concerned, every country that builds things, since the bulk of everything is built in China, I guess I have to question, do I worry more about stuff made in China or made in the US? I don't know. I think I'd rather get stuff made in the US, as far as, trusting the electronics go.
So basically, with all the craziness that we're hearing these days, the idea that things should be manufactured in the United States when it comes to security is not the craziest idea, and certainly we'll find a ready audience in the intelligence community that have been basically saying that for a number of years, that you can't trust a router that was built in China, or you can't trust blah, blah, blah.
Yeah, the American intel community is more concerned about, what the Chinese might do to the parts that they're building in China. Not so much that, oh, good, we'll build it in America so we can insert American backdoors. They don't have to insert backdoors, because the fact is that, it's all offense and no defense. The ability to penetrate a targeted computer is so powerful. You don't need a backdoor. I've heard American intelligence officials say that if this was a football game, it would be like the score would be, 350 to 320 in the first 20 minutes of the game, because it's all offense and no defense. So we don't need to, nobody has to engineer any backdoors. It's because it's so leaky, it's so permeable already. They can just get in at will. Look, Putin probably has all the Snowden material, but he probably didn't get it from Snowden. He probably got it long before Snowden ever got it, by just going after it in the American networks. And just like we can get into their networks. So I think worrying too much about, don't use hardware built in the US because it probably has backdoors. I don't think of it that way. I think they can just get in without backdoors. It's better. It's better to be sure. We have to put more on the defense, and that means.
But then the corollary of that to the original question is, if Europe puts very strong products out and proofs its networks, will they be allowed to interconnect with the United States?
Oh, sure.
Yeah.
Why not?
Well, I think there are a couple of things there, isn't there? Because Foxconn wants to build, or has been asked to build devices in the US, and it will if it gets agreement. But actually, we're thinking about this in a kindly off skew, if you like. In China, for example, if you're going to sell a device in China, there are various measures in place where manufacturers have to do certain things to those devices. But actually, when we look at the future, where we're going, and you look at your mobile device, currently there's encryption in place at the air interface between the SIM and the device. And governments would target that rather than the device itself and the hardware, I think. And also, but having said that, we're looking at a future where your SIM is embedded on the device. It's not that you pop into a shop and buy the SIM and insert it. It's that the SIM is embedded in the device, particularly in the M2M and the connected car, et cetera, et cetera. So the SIMs will be updated, particularly when you want to swap your handsets, for example, or give your handset to someone else. All of that will be done over the air, so OTA. So for me, that will be the target, the focus of compromise, those processes and those systems, really.
And I think Steph's making the assumption that somehow we would trust French technology to not have been undermined the same way that the US or Chinese tech might be, just a different way, or Belgian, using Gemalto as an example.
From the University of Edinburgh. So a possible way to end the current round of the crypto wars would be that end-to-end encryption wins and content is safe. And people can send messages to each other in a safe way without trapdoors to the actual contents. But nothing else is done. So my question is that, is this a win? And especially taking into account the question and issues raised by the panelists today about metadata. So maybe there's no trapdoor to your content, but there is another very big trapdoor, which is just listening to the network.
Yeah.
Maybe there are encrypted packets going back and forth. So the question for the panel would be, okay, if we were, like the crypto community was successful, like at least to raise awareness about end-to-end encryption and protecting the content, how important do you think is metadata and what we can do to make protection of metadata at least as successful and make people aware of it to the same degree that protecting content is?
I'll tell you, it's incredibly difficult to protect against traffic analysis. I don't know how to do it. I mean, in theory, I know how to do it, but it's not practical. You know, you can flood the network with bogus traffic, but then the internet becomes unusable. I usually don't even try. I mean, I try to a limited extent with my products because, you know, we have servers, so we could make it so that you talk through the server, so you don't have the IP addresses at both ends on every packet, you know. But that's very limited. It means that if somebody's observing your servers, they can see who's talking to who. Now, but on the other hand, it depends on your threat model. If you're trying to prevent the NSA from doing it, you're probably going to fail. The NSA will be able to see all the traffic because they can monitor so much of the internet. But if, on the other hand, you're a New York Times journalist who is in Damascus reporting on things happening in the Syrian... There was a journalist in Damascus who was using cell phones to communicate with her editor in the U.S. And, there were guys pounding on her hotel room door with guns, and she had to escape out the back. She got our products and started communicating, and it's secure just out of the country. And that problem was solved. Now, it went to a server in Montreal, and then from that server to New York. And in fact, that leg of it wasn't even encrypted, but she didn't care. She didn't care if the FBI could listen to her calling her story and it was going to be published the next day in the New York Times. The FBI could read it in the New York Times if they want, you know. Her threat model was those guys pounding on the door with weapons, you know. Her life is in danger, you know. So if your threat model is local, then there are ways to limit the traffic analysis. But if you're up against someone like the NSA, it's harder, much harder.
Seda?
Right. I guess one needs to go down a little bit like the history of software engineering and how the industry has optimized software engineering by basically moving from what's called shrink-wrap software. You know, you would go to the shop and buy Microsoft Word and install it, or maybe you'd open Office. And nobody could watch what you were doing, ideally, on your system, and you could, draft documents, to moving it all to services and to the cloud, right? Like now we have Google Docs or Microsoft 360, what have you. So we're not talking just about communications being the thing that happens or the web surfing being the thing that happens. We're talking about all of our computational activities being moved to the web. This is a transition that took place in the last 16 years, and no encryption is going to help us here, specifically either in the protection of the content, and it's definitely going to increase the collection of metadata. That sounds bad. It gets worse. The trend right now is to go for microservices, which means that you do one thing really well and you take other parts of your functionality from elsewhere, which means that most websites integrate about 20 or 30 other third parties who also integrate yet other third parties. So how easy will it be for both different industry partners and governments to hook in as a third party that is somewhere down the line and to get all this metadata? I think it's going to be a huge challenge, but I think the challenge is not just because we want to protect about traffic analysis, but we really need to look at the way the industry has normalized these kind of practices in the process of optimizing and making efficient software engineering, or cost less if it does, I don't know. But I think if we want to really look at this, we can't just be working on ways to protect against traffic analysis, but we need to change the way we develop and use software, right? So that not everything is online. I think this is very, very fundamental.
Just to remark a little bit to counterbalance. On the other hand, there might be very good reasons why law enforcement would actually have access to metadata. In practice, of course, I see these cases which are child pornography, mistreatment of children, murder cases, etc., where metadata are used by law enforcement to actually solve those cases, where you would actually be, as a victim, would be a proponent for those metadata to be used. Of course, within a certain system, where you've got a rule of law, where you've got a judge actually sanctioning the use of those data, afterwards checking on the use of that data, where it would be proportionate and within the limits that has been set now in Europe by the European Court of Justice, and where it is really proportionate. In that context, I think metadata, of course, should be used, because it is today one of the most important tools law enforcement is using. So I think we should there find a balance between, on the one hand, indeed intelligence services, of course cyber criminals, etc., and on the other hand, use of metadata, which is really important to solve criminal cases. And to find that balance will also be one of the debates that will be going on in the next couple of years.
Okay, thank you for these words and rebalancing a little bit, Catherine, as well. Maybe if you don't want to be woken up again by another bell, I would suggest one word maybe from Glyn, Pat, please, if you want to have one word to round up the discussion.
Okay, just to pick up on this metadata issue, it's very interesting that the UK government is very careful to say we won't touch your content without special warrants, but we're going to take all the metadata. So they've managed to frame the whole debate as if metadata is harmless. And I think that's a big issue we really need to address, because as we've heard, it isn't.
Pat?
So, in my dark past, I've assisted and given evidence in human trafficking cases, paedophile cases, terrorism cases. I know the importance and the role of metadata. But these laws are driving people to adopt alternative solutions because those laws are disproportionate, are unwarranted, are unnecessary in many, many ways. And I also just want to touch, Patrick, on the power of platforms. So there was a company that developed an app called Ad Nauseam to flood the network on the Android, on the Google App Store, to flood it with noise and advertising. Google banned it. So actually it's a really big debate about metadata and the choices people have over that metadata.
Phil, would you like to add something to this and round up the debate?
No,
you can do it. You can do it.
If we, because I don't have a technological solution to protect metadata, to protect the, observation of traffic analysis. I don't know how to solve it technologically. If we're gonna do something about metadata, we're gonna have to do it in policy space.
Thank you. Thank you all. Gus, Seda, Glyn, Catherine, Kat, Phil for the contributions. Thank you, the audience, and enjoy the rest of the day. Thank you.